So let's take a quick tour of the periodic table to see how the elements are organized. The periods of the periodic table are the horizontal rows, going from left to right, and then the vertical columns are called the families or the groups. So families, up and down columns of elements have similar chemical properties. That's why the periodic table was organized the way it is to begin with. The table as a whole has metals on the lower left side, nonmetals on the upper right side. So we have, iron, titanium, things like that will be found more toward the left. Oxygen, carbon are in the upper right. And then along the separating line, a staircase, would be the semimetals or the metalloids. So there's a couple elements that might be a little bit misleading the way that they're placed on the periodic table. Even though hydrogen is usually written on the left side of the periodic table, it is not a metal, it's a nonmetal. And aluminum, even though it's close to that staircase, is not a metalloid, it's a full metal. So I'll go ahead and show you a few of these things in your LibreText as well. So I just wanted to point out the periodic tables that are in your LibreText chapter 4.3. First, let's scroll down to where we see the metal, the nonmetals, and the metalloids or semimetals here. And then I just wanted to point out that aluminum is not labeled correctly. So aluminum should be a full metal, not a semi-metal. So along the staircase, generally we have the metalloids, but aluminum itself is not a metalloid. Even though it's along the staircase, we have a little staircase that goes down the periodic table. And generally the ones along this staircase are the metalloids, but aluminum is a metal. Also, even though this is the metal side of the periodic table, hydrogen is definitely a nonmetal. So this is labeled correctly, but the aluminum is not. In this particular graphic, if we scroll up to this particular periodic table, we do have aluminum labeled with this group of metals over here, and the metalloids not including aluminum, just these other elements along the staircase here. And hydrogen being a nonmetal over here. All right, we are probably familiar already with some differences between metals and nonmetals just in everyday life. We're going to be learning a little bit more about the chemistry and how they vary, metals versus nonmetals. But I think we're all familiar with metals being able to conduct heat and electricity very well, being malleable, which means that when you pound it with a hammer, you can change its shape. You can make something out of metal by pounding it with a hammer into a certain shape. But if you try that with a nonmetal, well, first of all, some of them are gases, so that wouldn't work. But even in solid form, those would be brittle, like a piece of charcoal. You can imagine a piece of carbon, trying to pound that with a hammer. It's not going to make a nice sculpture for you. It's just going to shatter. Also, a piece of metal like copper being shiny, and again, the charcoal not being very shiny. We've already talked about where they're located, and metalloids along that staircase have properties that are sort of in between a metal and non-metal. So they conduct a little bit, they conduct electricity, but not as well as a metal. And so that is a very important property to have. A lot of the semiconductors are made out of metalloids because you want something that conducts electricity, but not quite as well as a metal does. They tend to be slightly shiny, but not very malleable. So they are brittle and shatter easily. All right, so let's look at the more detailed periodic table in the Chem Libre text. So the main group elements are these two tall columns and these 6 taller columns on the left and right side of the periodic table. This lower area in the periodic table is the transition metals. A lot of times I think the periodic table looks like a castle, so we have the main outer walls being the main group elements. Inside the moat is the transition metals, And then down here in the dungeon is where we have the lanthanide metals and the actinide metals, which are sometimes called the inner transition metals. Then a few of these families have special names. The alkali metals are probably the most famous because they are very reactive. Throwing them into water causes very exciting explosions. We have some videos of that to see. The next one over is the alkaline earth metals. And then at the very end of the table, we have the noble gases all the way over to the right. They're called noble gases because they don't like to associate and bond and form compounds with other elements. Generally, they keep to themselves, so they're haughty, they're nobility. They don't like to associate with the other peasants. And then this next column over is halogens. So these are also very reactive, but in a different way from the alkali metals. So you even have a video about the alkali metals in the LibreText itself, and then I have another one on Canvas. All right, so let's go ahead and see if we can do problem 4.3.1. It's looking for the halogen in period 4. So the periods, remember, are the horizontal row. So this top row with hydrogen and helium would be period 1. This second row is period 2, period 3, and period 4. So this is period 4. And the halogens are this second to last column over here. We have the noble gases and the halogens. So the halogen in period 4 would be bromine. So here we have the halogen in period 4. So next we want the lanthanide that comes first alphabetically. So we have the lanthanides down here in this area, and alphabetically I think that the first one would be this cerium that starts with C. There's no A's or B's, so cerium would be the first lanthanide alphabetically. Then we want a metalloid in group 14. So the groups are numbered across the periodic table, 1, 2, 3, 4, 5. So the group numbers are not written on this particular table, but the copies that I have on Canvas for you to download and the second page of the note packet have the group numbers written on them. Okay, so here's a copy of that periodic table with the group numbers written 1 through 18. There is an old system where we had 1A, 2A, 3A, up to 8A down below here. But we are looking for group 14. And the metalloids in group 14 are silicon and germanium along this staircase here. So these are metalloids, and these would be the two metalloids that are in group 14. Then the last question asks for the transition metal with the lowest atomic number. So the transition metals are in this area over here, and the lower numbers are up in this first row, and the very lowest number is 21, so scandium would be the answer to that question. So since it's a little bit difficult in a video to be going back and forth and showing the periodic table, I'll go ahead and let you guys do these problems on your own as well and just check them against the answer key that I have posted. So hopefully using the periodic table you can find where all of these elements are. If an atom of an element has no charge, so we talked about if you have an isotope with nothing in the upper right, then that's a 0 charge. You don't usually write it, but you can, and that would be a neutral atom. If an atom has a charge, then that would be called an ion. Depending on the type of charge, the ion that has a positive charge is called a cation. An ion with a negative charge is called an anion. And we've already figured out how to calculate the charge on an ion. So something to note is that if something is positively charged, it means that it has lost some electrons, and if it's negatively charged, it has gained electrons. So what has changed is the number of electrons on the atom, not the number of protons. So the number of protons cannot change. the atom can either lose electrons and become positive or gain electrons and become negative. A lot of elements on the periodic table always form the same type of ion, depending on what group or family that they are in. So this I will show you on the periodic table. All right, this is a copy of the periodic table that is in your note packet, or you can download another copy from Canvas. And I wanted to use this to figure out the elements that have a predictable charge, where they are and what the predictable charge usually is. So this first group over here, group 1, will form ions with a +1 charge. So when these are ions, they have a +1 charge. This group over here. This group over here, the group 2, the alkaline earth metals, form a +2 charge when they form ions. Going over to the other side, the nonmetals form negative ions. The halogens form negative ions with a -1 charge. Oxygen, sulfur, selenium form ions with a -2 charge. Nitrogen and phosphorus form -3 charge. Then we have a little W over here. So these metals towards the top of the group 13, aluminum and gallium, are reliably +3 ions. If you get lower down, it's not as reliable, so we'll count these as a +3 in this little W area here. Then zinc and cadmium, even though they're transition metals, they always form +2 ions. And silver, even though it's a transition metal, it always forms a +1 ion. So these elements always do the same thing when they form ions, so that makes them predictable as well. Other elements that are not color-coded like this, the other transition metals, are variable. So they can form different types of ions. For example, iron can form an ion with a 3+ charge, or it can form an ion with a 2+ charge. We can't just predict from its position on the periodic table what sort of ion it's going to form. So iron is not predictable. So the predictable ones are shown here. Okay, so let's take a look at some of these problems here in the note packet. So an ion that is negatively charged is called an anion. With a positive charge, it's called a cation. And remember, the charge is the number of protons minus the number of electrons. So in this particular example, we have 11 protons, 10 electrons, so the charge is a +1. And something with 11 protons is a sodium atom. So this would be a sodium atom with a +1 charge. We don't really know the isotope because we don't know how many neutrons are there, but it would be a sodium ion with a +1 charge. So we could just write it like this. In this particular case, we have 15 protons and we're subtracting 18 electrons, so that would be a -3 charge. And then that is element phosphorus with a -3 charge. So magnesium has 12 protons. We can tell from its atomic number on the periodic table. So the electrons we can calculate by taking the number of protons and subtracting the charge. So that is 12 protons. 12 protons minus a +2 charge. So there would be 10 electrons on the magnesium +2 ion. So for this problem here, we have to look at the periodic table and see if it's in one of these families up here that we are told the predictable charge. Sulfur is. When sulfur forms an ion, you can have a neutral sulfur atom, but when sulfur forms an ion, it would form an ion with a -2 charge. It never forms a +1 ion or a -3 ion. It would be a -2 ion if it does form an ion. So remember, all of these can be neutral atoms without a charge, but this is when they form an ion, what charge would that ion have? And for calcium, if it does form an ion, it would be a +2 charge, and for phosphorus, it would be -3. For sodium, it would be +1. It's in that first group of the alkali metals. Iron is a transition metal, so it has different ions that it can form. It's variable charge. Magnesium is in that alkaline earth metals. It would form a +2 charge. Nitrogen, when it does form an ion, would be a -3 charge. Fluorine is a halogen with a -1 charge. Gold is variable. It's a transition metal that has variable charge, and so is titanium. Strontium is an alkaline earth metal, so that is a +2 charge. And silver, even though it's a transition metal, it's in that little corner of predictable charge transition metals, and silver, when it forms an ion, is a +1 ion.